Good morning, Dave Kenworthy. It's the 19th of the 10th, 2021, and yesterday we looked at the first phase of Stonehenge using the work of Thom and Stukeley, and using Stukeley's diagram that produces a second circle outside the Aubrey circle of 56 post holes, Stukeley's circle having 52 post holes. And we went through the mathematics of it. And eventually we focused on Thom's circle of 56 post holes, the Aubrey circle, and looked at the complex mathematics involved in this number 89760, and in particular the fact that it's 897.6 feet. And these ancient designers were not using decimal places, so we need to take the decimal place out of that by multiplying it by 100 on the assumption that these people were using 100 units in a foot, because this works perfectly. And then we were able to break down the versions of pi, the three versions of pi, so we've got pi cubed within the Aubrey circle as 89760 divided by 2912, giving that for pi cubed. And of course, because the Aubrey circle is 89760, we need to multiply out this 2912 days. And when we do, we don't know it's there. We've just got 89760. We have no idea till we put this variable pi calculation together that 2912 is in the calculation. We just get 89760. But when we realise that that's actually there, we can then work out what 89760 is actually represented by, and it's 261,381,120 divided by 2912. So the design is 2912 days, giving this circumference, which is a fairly large number. But from Plimpton 322 we know they were very capable of dealing with very large numbers. Then we went through the versions of root 2 and root 3 that are built into the versions of pi, and then we looked at the cycles that they were using, the 6600 extended Saros and 6800 nodal cycle. And today we're going back to this variable pi calculation, and we're going to look at prime numbers that are involved in this 261,381,120. And the best way to do that is to go onto the internet and call up a program called Numbermatics, and we just bring the program up, and then we have to enter into it this number 261,381,120. So we go back into Numbermatics, and it's 261,381,120, and Numbermatics will tell us everything about this number. It's an even composite number composed of 7 prime numbers multiplied together. It's 2 to the power 10 times 3 times 5 times 7 times 11 times 13 times 17. It contains all the primes to 17. And 2 is taken to the power 10. Now when I saw this, I realised immediately that it's deliberate on behalf of the designers. This is something that I keep repeating, but it's very true. So another thing I realised is if you get the rod 16.5 and multiply it by 32, you get 528. If the rod is 17, 17 being built into the megalithic yard as 16 times 17. If you multiply 17 by 32, you get Thom's mile. So Thom's mile is the English mile times 33 times 34 divided by 33. And both of these units have got 16 built into them. Sorry, 32 built into them. And we can see that that's here, 32 and 32. So I looked at the construction of the English mile using prime numbers. So we start with 32, we multiply it by 1, then 3, then 5, then 7, and then 11, and we get this number 36960. We divide it by 7 and we get 5280. So the English mile is 36960 divided by 7. And 7 is the denominator in pi as 22 over 7. And 5280 is 240 times 22. So we can see immediately that the imperial system was being used to count periods of 22 days. And the ancient designers were counting base 11 as 2 times 11 as 22 days. They were counting periods of 22 days. And 22 days in weeks is pi weeks when pi is 22 over 7. And this is what they were using at Stonehenge. Now we carry on with the missing units. And they are 32 times by 1, 13 and 17, which gives 7072. And we divide that by 13. Again, the denominator in Thom pi, we get 544. And that 2872,320 is what you get when you divide that by that. So we can see that the Aubrey circle, when it's expressed as 89760 times 2912, it's constructed of two systems derived from the primes from 1 to 17, where the numbers are multiplied by 32. So we're using 2 to the power 10 in the whole construction. And this is absolutely deliberate. And we know that Thom pi is 17 divided by 13 multiplied by 24 divided by 10. That's Thom pi that we've been using. And the other version of pi we know is 11, 7, 2, 1. And that's it. That's what they're using in this system, this prime number system, where 36960 divided by 7 is 5280 and 7072 divided by 13 is 544. So the unit in Thom's system, the mile in Thom's system, is 5440 miles. And Bill Wilkinson, in his YouTube presentation of the distance between the sanctuary and Woodhenge, gets 81600 imperial feet. That's the mile. 15 miles between Woodhenge and the sanctuary. 15 Thom miles. And this is what we have to realise when we're looking at these systems. There are two individual systems that have been melded together using prime numbers to get this huge number here that effectively is 89760 multiplied by 2912. And why are they using 2912? It's 8 periods of 364 days. And what are they doing at Stonehenge? They're counting 365.25 every year. And that is the solstice year. And it's the midsummer sunset, midwinter sunrise year. 365.25 days. And 364 is 1.25 days less. They're counting an 8-year period, and that's the sacred number of days between 8 natural years and 8 astronomical years. And the reason why I'd call these astronomical years is because these people were scientists. It's what Thom tells us. They were conducting a scientific experiment to determine the motion of the moon so that they could learn how to predict eclipses and know when one was going to happen when there was a wobble of the moon. Now, every year you must have consistent information. And what they were doing, they were having 4 91-day periods and then a 1.25 day period at the year end, so that every year started at the midwinter sunset. So the new year would start then, and they'd start it the following morning at daylight, and they'd have 365 days running round the circle at Stonehenge, and they'd have 364 days being recorded as an 8-year period, and every year there'd be a 1.25 day lag. So at the end of the 8-year period, there'd be a 10-day lag between where they were at 365.25, the same point every year, and every year they'd be dropping back 1.25 days until there was a 10-day lag, and then they'd do a reset. And the reason they were using an 8-year period is because they were counting the Venus cycle against the 365.25 day cycle. And they did that because they knew that the difference in the cycles was 0.3 of a day. So the Venus cycle was that. (2919.6), and we can divide that by 5. And that's what they had as the Venus cycle that they were counting, 583.92 days. That's the same as what the Mayans were doing. They were doing exactly the same thing at Stonehenge. And I've written about this in my book, The Eclipse. And there's a unit that they're using as 0.3 of a day. And if we multiply by 5280 by 0.3, we'll get that unit. 1584. That's the Venus unit. If you read my book, The Eclipse, I've called that the Venus unit. It represents 0.3 of a day, and it represents this system that they were using. So they were going 2922, going 2919.6, and they were going 2912. And that's how they were counting these astronomical periods. And that's the reason why they're using 2912 within the design of the Aubrey perimeter, which is where we're at now. So I'll leave it at that for now because there's a lot to think about there, but I'll stop with that. But that's the reason why I believe that there are 2 circles in Stukeley's analysis, and the second one is 52 post holes, because 52 times 56 is 2912. So thank you.